Hey, today we talk about Arduinos and Arduino accessories or shields or parts that you can use with an Arduino. I built a lot of ghost detectors over the last years, and some of them are lined up in the background here. Well, I'm not an electronics engineer or any sorts. I'm a noob playing around with stuff, but all of my ghost detectors are based on Arduino boards. And a lot of you have, well, never, used one of those things and are not into electronic and all this stuff. You are more into the actual ghost hunt, and I understand that. That's why I'm making this video, because today I thought, hey, let's build along a very simple device that you can use on your next ghost hunt. It does not have to be that complicated all the time with a lot of code, a lot of wiring and stuff going on. Of course, I don't want to be concurrent to a professional manufacturer of those devices. They use different components, they are more sophisticated and stuff like that. But already with an Arduino board and the sensor and some stuff, we can do pretty awesome stuff. Best example was at Big Life's YouTube channel some years back. He made an EMF detector, an electromagnetic field detector, by only using a couple of transistors, a resistor, an LED and a battery, and maybe like 10 minutes of soldering time. So you can build pretty cool things without too much, electronic knowledge. And that's what I want to do today. So first off, I want to explain to you what an Arduino is and how they work, more or less, because there are hundreds, if not thousands, of videos about Arduinos online. So I'm not going too deep into that, but I will explain you the basics. I will explain you what we can build actually without, having so much knowledge about everything. We can build a little nice device that will be pretty cool to use on your next ghost hunt. For that, I will put you up there to have a top shot view, and we will get into it. Now, don't let those pieces scare you. I just put them out for a little introduction into Arduino boards. Let's start with this thing. This is called an Arduino UNO. This is a copy of it. You get a lot of manufacturers nowadays who are building the exact same board. And they all work with the Arduino IDE that you can download for free online. So what basically is this thing? Well, we have a microprocessor here in the middle. We have a crystal and a lot of other components in order to make this thing work. USB, often those boards come with an adapter, because this is still this USB-B, or what was it? The older kind of USB to a regular USB plug you hook up to your computer. You have an input for voltage. This is not needed as long as you power the board from your computer. You have these headers here and there. Those are basically numbered from here 0 to 13, and those can be configured as an input or output, so they can be both. That's something you can program very simply in the Arduino IDE. On the other side, we have kind of the same thing, but it says A0 to A5, which stands for analog. These can be in and outputs as well, but analog, and I will explain you later what's the difference. Then you have like 5 volts output, you have 5 volt input, you have ground, you have 3.3 volt output, and so on. Now, this is a regular standard board, and as I said, it has these headers here because they are meant to be used with a patch wire, and those patch wires you can order on Amazon. They often come in packs of 50 or 100, and you can simply stick them in there and hook them up to whatever you need to, and you have a connection. Now, for a lot of projects, this board is way too big. So that's why they have the Arduino NANO. This is also a clone, but it is basically, again, the exact same thing. It has some fewer outputs and inputs and PWM channels, but that's something we not care about right now. As I said, there are so many videos that you can watch about Arduinos, but it's basically the exact same thing than the big one. You can hook it up via micro USB or mini USB. Also, there are different versions. Some of them have micro, some of them have mini USB. However, the workflow is the same. You can upload your code that you have written on your laptop, upload it to the boards. When you build like a bigger project where you need way more in and outputs and stuff like that, there are also things like this one. This is an Arduino Mega. Way more inputs, way more outputs. You see this header here. I think we have 53 in total, 53 in and outputs. Rarely that I used something like that, but it can come in handy depending on what you do. You can run out of ports quite fast. However, today what we will do is we will use the Arduino UNO because it's easier to work with, and then we use a breadboard. You probably heard this word a couple of times, and you probably also know what it is, but again, just to show it to you, this is a little tiny breadboard. This is used to patch. We use the same patch wires, and you can plug them in here and you can hook them up to something else. This is all there is to it. And then you have two rails here and there where you can put in 5 volts positive and negative or ground, and this comes in handy especially when you work with an Arduino Nano, because they don't have these headers anymore. I already soldered in the pins here. Usually they just come as a PCB and you have the headers next to them, so you have to solder them in manually, because you can solder wires directly to the terminals here. So with a breadboard, however, we can now insert this into our well, we can insert the Arduino Nano into our breadboard like this, and then from there we can patch to other devices or things we need to. So a breadboard, you see that it is divided in the middle, and all those rows here, those are all connected together. For example, now when I say I want to go from D7 digital out 7, I hook this in here, I plug it in here, for example, and then from there I can add, you know, a resistor or an LED or whatever. Then we have, well, let's say input devices. What is an input device? Well, an input device can be a switch, for example. It can be a simple switch that can be turned on and off. It can be a momentary switch that while it is pushed, it closes the circuit. Then we have potentiometers that we can turn, so we can adjust a value to something. And here is the thing that comes in importantly when we work with Arduinos, that for example, a switch or a momentum switch, when we push it, something happens. When we let go, nothing happens. So for example, I could hook this up to pin number 2 here and to ground. I can then write a little code, and when I push this button, there's a little tiny LED integrated on these boards. This LED will light up when I push the button, or it stays on, and when I push the button it goes out, depending on your code. Now, when I use a potentiometer, for example, we have a lot of values. We have not just on and off, but we have 0 to, let's say, 255. So we can adjust those values, and in order to adjust it, as this is called an analog signal, and an analog signal would mean we have to hook it up to an analog input. It's not a constant signal, but it's a signal that varies. But also we can have sensors as an input built into our circuit, and we have hundreds of different sensors. For example, this is a microphone sensor. So it comes already ready, soldered together. When you search for stuff like that on Amazon, for example, write what you're looking for, like microphone, and then write Arduino behind it, so Amazon knows what you're looking for. So it already shows you most of the time a little device that is made exactly for the Arduino, that uses the right voltage, etc. So you see, we have a little micro here, we have a little potentiometer here, so we can adjust the sensitivity of this microphone, and we have 3 pins. Most sensors have 3 pins. Well, why that? Because you have voltage in, you have ground in the middle here, and you have the output of the microphone. So we could wire this up in order that we get 5 volt from our Arduino board, ground from our Arduino board to ground and voltage, and then the output we could, for example, hook up to digital input 2 or analog input A1 or A0 or whatever we choose. It also depends what should this mic do. And again, that's the thing about analog and digital. When we want something like a clap sensor, that when we clap it turns on a light, we can use a digital in and output. If we want this microphone to be sensitive to, let's say, it measures 30 decibel all the time, and then when it peaks at 35 decibel, for example, the light should turn on and or off. We would need to use an analog input because we have a variable. However, we don't need all this right now for now. What else do we have? For example, this little device is pretty awesome, and I think we will go with that today for our build. This is a temperature sensor, and it's not only that, it's also a humidity sensor. So it does both in the same time. It's a little tiny device. It's a scent product, especially on AliExpress and things like that. So it's a very tiny sensor. You see, you can carefully bend this upwards even. You could theoretically also unsolder this, what I already did sometimes, and then solder up wires in order to put the actual sensor on a different spot and keep this part here somewhere hidden. Infrared bridge, so you have an infrared LED and an infrared receptor, so when they hit something on a certain distance, which you can adjust with this little potentiometer, it will turn on a light. So light off, light on, light off, light on. Same thing. It acts same manner as a switch, so it's the same thing basically. Now we get more complex things also. For example, I have a PIR sensor here. You know, these are the things that you usually find in your outdoor cameras or lights that go on when somebody passes by your house or something. And you also get these as an Arduino shield or Arduino component. So if you want to build, for example, a motion detector device for your ghost hunt, you could use one of these, for example, together with an Arduino and a buzzer or an LED, for example, that turns on when something moves. You can even hook up a motor, like a servo, or even I have some stepper motors here, something like this. You can hook up motors, but you cannot hook them up directly to an Arduino, and that is why, because an Arduino board can only supply certain amounts of voltages and amps. So they are very sensitive because they are, well, it's a microprocessor. So you cannot power something big like a motor or something using an Arduino board directly, because it will burn it and you can throw it away and get you a new one. So this is why, for example, with a stepper motor or with a servo, you would need some little device here. It's still in the packaging, but I just recently got that, if you have seen that video. This is a little PCB board that actually on one side hooks up to the Arduino, and on the other side it has voltage that goes in there. It has the right transistors and everything in order to drive something like a motor like that. And this particular PCB can drive up to 12 of these servos controlled by an Arduino. Not necessarily used for a ghost detector, but, well, you know, just to let you know. For example, an MP3 player, and this is how this thing looks like. This is basically a tiny little PCB, and it has an SD card slot on the side, so you can put in an SD card with sounds or noises on it, or voice or whatever. And you can hook this up to an Arduino, and something passes in front of this detector. Instead of turning on an LED, it plays a sound coming from this SD card. Sometimes they even come with an integrated amplifier, so you can hook up a speaker right to it. Sometimes you need another little device, another little amp, basically, to drive a little speaker. Just for an example, can be quite fun. I experimented with those things too. Those are basically pretty cool, but this is more advanced stuff. But just to let you know what are the possibilities, this is basically a wireless transmitter that can be hooked up to an Arduino board, and you have a second one on the receiver end, and you can send stuff over, it's not Wi-Fi, it's RF, I think. And those things are quite capable. I reached quite big distances using this device. For example, when you want to turn on an LED or something, or you have, as I said before, this motion detector thing hooked up to this Arduino, let's say, and you add this to it, you can remotely put this somewhere. Of course, you would need a battery. Put this in a room, and then in the next room you have the receiving unit. You can hook up a screen to it where the readout will come in, and you will receive them wirelessly. Can be very cool for certain projects. I used this, by the way, in my project with my radar, the Ghost radar that uses LiDAR. And one of these stepper motors actually that spins the LiDAR detector 180 degrees, and it paints a three-dimensional or two-dimensional graphic onto a screen in real time, and all this goes wirelessly over one of these components. However, we always need some resistors. Let's say we want to build a very simple ghost detector based on temperature and humidity. Often they say that when there are spirits or any spiritual things going on, that the temperature would drop suddenly in a room, for example. And we can detect that. Using one of these sensors here, for example, we can use an Arduino board, and when you turn it on, it reads the temperature, and then it takes, let's say, 10 readings, and that can be 10 readings per second or even more, and it says, okay, we have 23 degrees centigrade in this room. And from there on, it compares. It always reads the temperature inside of this thing, and it says, okay, it's 23 degrees, and suddenly temperature drops to 22 or 20 degrees. And the Arduino will recognize that and will say, oh, there's something going wrong, something's going on. And then it will activate one of those pins, for example, which can be a buzzer, an LED, or whatever you want to hook up to it. You can even hook up, that's another build I once made. I took a little gear motor that cranks the shaft of a little music box. You know, you can be creative with this stuff. Here are my buzzers. And when it comes to buzzers, I learned the hard way that there are two different kinds of buzzers. They're called Piezo Buzzer on Amazon, for example. And the thing is that you have buzzers that do not much when you hook up a voltage to them. That's because you have buzzers that need an integrated circuit actually in order to buzz, because regular buzzers need an external little circuit in order to create a frequency to make them buzz. So watch out when you buy them or when you order them online. There are differences in those buzzers. Let's see, I just have my bench power supply here, and I will just try, when I hook this up, if these are the right ones. So here's the positive lead. Let's see. Yes, okay. So you see, this is what we want actually. And I don't know where I have the other ones, but be careful, as I said, because you get buzzers that are really just the piezo buzzer itself without any frequency generator. And you need some sort of frequency to make this thing vibrate and produce a sound. So, but usually in the description on your Amazon shop, you can see this and order the right ones. All right, we have everything together here for our build. I use one of these 4 AA battery holder things. This comes out to about 5 to 6 volts that we can easily connect to the Arduino later on for powering it. For now, we don't need it yet because power will be supplied via USB while we are programming all this and building this project together. So for now, yeah, I chose an Arduino UNO for this project. Of course, as I said, you can use the Nano one. There are even smaller ones than Nano, but for now, to keep it easy, because we have already these tabs here, I used the Arduino UNO board. So let's first off power our breadboard. So we have multiple choices here. We have VIN, which means or stands for voltage in. That is where we will hook up our battery compartment later by putting this switch in between. And then we have ground next to it. So that will power our system later on. But for now, as I said, we don't care because we will power it from our USB port right now. But we need 5 volts supply power, and we have 5 volts here on this tab. So now when I hook this up to the breadboard's power rail, now we need ground, which will be next. It's next to the 5 volts. So as I said before, the power rails and the ground rails, they are horizontally connected together. Other than these pins, those are vertically connected together, but divided in the middles. Now, next we go to our I think it's a DHP11 module, temperature and humidity sensor in one single little unit. It has 3 pins. We have VCC, which stands for 5 volts voltage input. We have the middle pin, which says data, and we have the ground pin here. So I will hook this up as so. I will plug this in here. Now, first off, let's connect ground. So we have ground on the outer edge of this thing. So I can simply hook this up to our ground rail as so. Next, we do the same thing with the 5 volts power supply. So I go tap into this section here and I connect this to our 5 volts of the Arduino board. Now for the data line. We need a data line and I choose yellow for that, and that's the middle pin. So the DHT11 data line hooks up to digital pin number 2 on our Arduino board. And when we look careful here, it always starts with 0. So count the right manner. It's not starting with 1. So we have 0, 1, 2. Theoretically, we already hooked up our sensor. And yeah, the only thing left to do is to hook up our little buzzer. Again, as I said before, when you order these buzzers, make sure you order the right one, the ones that beep when voltage is applied. Others, as I said, you need a little crystal, I think, in order to make them beep, because you need some sort of frequency in order to make it work. This has all this already integrated, so when I hook up 5 volts or 3 volts to those little pins here and check on the polarity, it usually says here, it will start beeping. So I will put this all the way in the back here, as so. And now we have to hook this up. So let's first hook up ground, which would be here, to our power rail here to the negative pin. So ground to ground. Now we have the positive pin. So I hook up the positive pin, and this, to my code, goes onto pin number 3. So it's right next to the other one, right next to the sensor. And basically, we're already done. I mean, we will put in the little switch later, but for now, this should work. So now I go ahead and power this thing up, and I will now take you over to the computer in order to show you what's going on. Now let's go to the software part of Arduino. So we need the Arduino IDE software. We go to arduino.cc, and here on products, software, and here you see Arduino IDE. We click on it, and here you have the options depending on what operating system you're using. I'm using Windows. You download it, you install it as you would with every other software. Now when you open Arduino IDE, it will greet you with this boring gray screen, which is still empty. So you go to my webpage, and I will put the link in the description below, where you can download the file. And when you open the file, it will open it in Arduino like this. So this is what you should see when you download this. Now, this is basically all there is to the code that we need in order to build our ghost detector. I'll go over it quickly. The thing what we need to do first, especially when you just downloaded the Arduino IDE, we have to go to Tools, and we have to select the board. You go to Board, Arduino AVR boards, and here you have a list of all the Arduino boards available for now. You can always add some, but for now we have everything we need. For example, the Arduino Nano, we have the Arduino Mega, we have the Arduino UNO Mini or UNO. I'm using the UNO, so that's why this is already selected here. You select the board you're using. Then we go here to port, and when your Arduino is hooked up to your computer, it should give you a port number here. It can become 1 or 11 or 9 or whatever. This is just the COM that the Arduino software can talk to the Arduino board. So you make sure you select that. We have to include a library for the sensor we're using, because we're using a DHT11 sensor. And sometimes this library is not already installed when you download the Arduino IDE. So I will show you how you do this. It's very simple. You can go on this icon here, or you go to Tools and you go to Manage Libraries. And up here in the search bar, you type in DHT, and it will give you a whole list of libraries. And which one we will use will be the DHT sensor library by Adafruit. You install that one, and that takes a minute or two, and then you should be good to go. You can verify if the code works by clicking on verify up here. If there is any error, it will pop up a window where it says in line 62, for example, you forget, you know, something or whatever. But as I have this code uploaded to my board and it works, it should be fine. Now, we have installed the DHT library, and let's say we verified that the code works. So we are basically ready to go. You could basically click on upload and it should start working. But let's go through the code very quickly. I skipped some of the things, but important is define. We need to define the pins where we want to hook up things to the Arduino board. In this case, I called it the DHT pin. This is the data pin from our DHT11 module or sensor, and I put it to 2. That's input 2 on the Arduino board. If I would put A2, it would set it to the Arduino analog input 2. But in this case, we keep it simple, so we just put DHT pin 2. So we hook up the data cable to pin 2 on our Arduino board. Same goes for the buzzer pin. I defined to port 3. So the positive terminal or plug of your buzzer pin goes to output 3 on your Arduino board. Next, we have some definitions here. They are not that important, but these two things here are basically the thing that you can play around with. This defines the temperature change that needs to happen in order to make this thing go off. In this case, it's 1.5 degrees centigrade. So when there's a difference, like it goes up or down 1.5 degrees, it will give you an acoustic signal or an alarm. Same thing with humidity, but in this case in percent, when the humidity rises or lowers 5%, it will also trigger the buzzer. And I made it in a way that both acoustic signals sound a little bit different, so you know what basically changed, if it was temperature or if it was humidity. We have the void setup. That is basically what starts up the Arduino board. Serial begin, everything that says serial in front of it is only for the serial monitor. And we can call this up going to tool, serial monitor. And when we hook up our board, it will show what's going on. Later on, you will see that it will say the temperature value, the humidity value, and the values that changed. So we have a visual what's going on. But of course, when you disconnect this from your PC, you will no longer be able to see it. So this is basically for what we call debugging. So we see when something goes wrong, when there's no reading, for example, or your cable, you know, from the DHT board is broken or something doesn't work, it will show in the serial monitor. Now, DHT begin, so it will start reading signals or reading data from the DHT module. First, what the Arduino board will do, it will wait for 30 seconds or 30,000 milliseconds. I did that. You can pull this down. You can put it to 1 or 10,000, which will be 10 seconds. This is to stabilize the sensor so it can acclimatize to the room temperature and humidity to give a solid reading that doesn't change or fluctuate too much. And while those 30 seconds are running off, it already tries to read signals and data from our sensor, and it does that every second. You can put this even down, so you can put this down to 100 milliseconds, for example. So it reads the data, but it still waits. It's still in the waiting mode, so it will wait 30 seconds, and then as soon as the 30 seconds are over, it will read a baseline temperature and a baseline humidity. That's the value it will compare any temperature drops or humidity drops. When this is done, we have baseline humidity, baseline temperature values. Then the Arduino will go over to the loop, and the loop in an Arduino board is the thing that, as it says, loops over and over and over again. As long as the Arduino board is on, at least in normal codes, this will go on as long as the Arduino runs. So it will permanently check temperature, check humidity. It will compare it to the baseline we already created. And when something happens, when the temperature drops, for example, it will start beeping because it says, "Oop, there is something that is significantly different than detected before. So it will prompt in the serial monitor significant change detected, and it will start buzzing. And I did two different sort of buzzings, so you know later on acoustically what's going on. When the temperature changes, we have three long beeps of 1 second each. So you know, okay, the temperature changed. When humidity changes, it gives you 4 acoustic signals, but very short. So it gives you 4 very short beeps. So you know acoustically what's going on. And that's basically it. And well, if it waits another second before the next reading, you can also bring this down and experiment with it. I mean, this is a value you can change. These values you can change if you want to change the beeps. And up here, these are the values you can change in order to make it more or less sensitive. For example, when you use it outdoors and there's wind, you probably want to crank this up to like 2 degrees or 3 degrees even, because when there's wind coming, you know, your temperature threshold will fluctuate more than in an indoor room. So that's basically it. So everything you need to do now is hook up your board and go up here, and then you click upload. And when this is uploaded, you can open the serial monitor, and it should start with a prompt where it says waiting 30 seconds. Okay, so our little build is almost done. I will disconnect this now from the computer, and usually I would now go ahead and wire this all up permanently. I would solder on the sensor, I would solder on the Piezo Buzzer, maybe even to a little PCB or something, and then run the wires directly soldered onto the Arduino. We still need to do one more thing. We need to hook up all this thing to run from batteries. So what we would do is we would run ground to ground. And there it doesn't really matter if it's the first ground or the second ground. I will not solder this up right now. I will just simply go ahead and take off a little bit more of this insulation here. Now when I hook this up, and now I can turn it on and off with a flick of a switch. Now again, as I mentioned before, I turned it on, so it will take 30 seconds in order to calibrate this little thing. And as soon as it is ready, I will try with some cold spray to trigger the buzzer. Of course, we could add another LED that shows us, that blinks up when the system is ready. We could also add LEDs that blink to the buzzer. But today we said, hey, let's do something very, very easy. And it seems to be now reading the sensor, because you see that LED now is flashing. So let's try some cold spray here. Just a tiny little bit. And you hear it's working. That's for temperature. And the 3 short ones are for humidity. There we go. So we have changes in both. And now as it thaws and it goes up in temperature, of course, it repeats the beeping until it reaches the room temperature. So now that we know that our system works, yeah, it's time to find a nice housing for it. As I said, I'm not soldering everything together right now, because for me it's just prototyping. But if you solder everything up nice and neat, and if you maybe even use a little Arduino NANO board, it makes the entire thing way smaller. You could use a rechargeable lithium-ion pack. You know, those are available in tiny little sizes, even sizes that probably will all fit into a little box like this here. I just got a few example boxes, this one, or maybe like, you know, one of those little Pelican style boxes. You can drill some holes in it from the on and off switch, maybe some little holes for the speaker or for the piezo, and you have a nice device that you can, that even has a strap, so you can turn it on, flip it on, put it somewhere, position it somewhere in a room, leave the room, and listen for acoustic signals. Another cool thing you can do is, of course, you could 3D print yourself a housing for it. This is a tiny smoke machine I once built, and yeah, you could use that, of course, in order to make something that really make everything fit together in nicely. Another thing is you can go around your place. I have a lot of, you know, used plastic boxes that I often keep. These are boxes, you know, for electronic components and stuff. You can use that. You can spray paint them. I used to spray paint them from the inside so they don't scratch that easily. So you could spray paint it black, put everything in there. You can always make it out, or put it open to replace the batteries and stuff. Here in this case we also have a latch on it. That could work. If we use an Arduino Nano, maybe an old cigar box could work. Pretty awesome are, of course, things that already have a certain look to them. I often go to flea markets. Old Second World War era flashlights, for example, are cool, or maybe even something like this. This is still working, so I don't want to break it, but you know, you have a big knob, so you already have a hole for the on and off switch, for example. You could repaint this. You could even add something like you could actually desolder this little blue sensor unit and build something on top on here that the sensor is exposed, and maybe a cage around it. You know, there are no limits to creativity, so you could make a lot of cool things with it. And yeah, that's basically how I build things like this. And I hope you build this thing with me, because as you see, this is very simple to do. Only thing, well, the hardest part is to understand more or less how coding works. And even there nowadays, you know, with ChatGPT and everything, it became very, very easy. So rather you 3D print some little bracket or some little housing for this thing, or you find something old, cool looking. As I said, go to some yard sales, go through your grandpa's garage or something, you know, to find something old looking, even keep it looking old, you know, it adds to the actual, you know, device. And to me personally, this is always the biggest part of fun of projects like this, to find something where I can put it in to make it look very interesting and very expensive. As I said, 3D printing is a nice way too to make something look a little bit more military or modern. Or, for example, an old box and you spray painted some paint, some color of your choice. However, as you see, you can build stuff like this quite easily. Of course, we could replace now this temperature sensor and replace it, for example, with a microphone shield that I showed you in the beginning. Do the same thing, you know, we set a threshold for the loudness, and when a certain threshold of volume gets surpassed, it gives you an alarm. We could, of course, now add a wireless transceiver and have a second bracket that you clip on your jeans, and when in some remote area, room or wherever in the house, something changes, it will notify you. On the other hand, the beeper is quite loud. We could, of course, add a switch to the beeper that switches between the piezo speaker to a little LED, so you just see a flash of light instead of a noise. If you don't want to scare anybody away or something, you never know. However, I hope you saw that you can build pretty cool things without tons of, you know, stuff you have to do. This is a nice weekend project. Let me know in the comments if you tried this thing out, if you maybe tweak a little around with the settings, with the maybe temperature thresholds. You can make them smaller or bigger, as we saw. So yeah, a lot of options there in order to refine this system. I will put back all my stuff now into my shelf here, before I will probably go ahead and think about some new projects I want to build with you guys. I hope you enjoyed this video. Please let me a comment if you like this stuff, subscribe, all this nice stuff, and I see you in the next one. Until then, see ya.